Okay, geometry students, we are going to be talking about the Pythagorean theorem, okay? Now, this is something that you guys probably have seen last year in ninth grade, and so this is probably not going to be anything new to you, so more of a refresher course. So let's go ahead and get started. Now, the Pythagorean theorem only deals with right triangles only, okay? So in my picture here, there is my right angle. Now, let's just go ahead and make sure that we're clear with all the parts of this triangle, okay? The angle, or I'm sorry, the side that is opposite of the right angle is called the hypotenuse. Okay? And the other two sides are what are called the legs. Okay, so this is a leg, this is a leg. Okay, these legs are interchangeable. Okay, and we'll get more into that as we go through. Now, there is a special relationship, a special formula that um, works with right triangles, and that is that the leg squared, when I square the length of the leg, plus the leg squared again, the other leg, I would get the hypotenuse squared. Okay. Now, sometimes you guys will be hearing, rather than saying leg, it'll be A, and then you have B, and then C. Okay, that's usually pretty popular with Pythagorean theorem. So if that's the case, it would be A squared plus B squared is equal to C squared. Okay, let's go ahead and just dive into a couple of problems. Now, here's the way that I've set this up. Right now, you are looking at about four problems. Okay, if there's any time during this video that you want to pause and work through some, feel free to do that just to kind of get some extra practice. And so what's going to happen at the end of the video is I'm going to scroll through the key, and then you could check your work as I scroll through the key. So right now, if you wanted to pause your video, work on problems 1, 2, 3, and 4, knock yourself out. Okay, but I'm going to go ahead and start with what I would probably say the most basic one, which is problem number 2. Okay, so let's go and dive into this. Notice what we're looking for. Here's my right angle. There is my x, so that means I'm dealing with the hypotenuse, okay? Now, using the a squared plus b squared equals c squared problem, notice I have 4 and I have a 3, okay? These are both my legs, so this could be a or b, or it could be b or a. Uh, these are pretty open-ended on how you can set it up. So I'm just going to go ahead and make a 4. So that would be 4 squared plus 3 squared is equal to my hypotenuse, which is c squared. Okay? And then the way you'd solve this is 16 plus 9 is equal to c squared. So when you do the math, you get 25, which is equal to c squared. All right, so you have 25 is equal to c squared. Now, at this point in time, we need to solve for the square. Now, a lot of folks are going to say, oh, that means it's 25 divided by 2. No, that's incorrect. A square represents what is one number that can be multiplied on top of itself to get another number. So that's our square root. So I'm going to square root 25, and I'll get 5. Okay, so that means 5 is my answer for C. So my answer is 5 for problem number 2. Okay, let's look at problem number 1. Notice what we have here is here's our right angle, and so the side that is directly across the right angle is my hypotenuse, so this is going to be my C. I'm just going to make this 12 my A, and then this is my B here. Okay, now could I have switched it up to where this is my B and this right here is my A? Yes, you could have, but I wrote this first, and I'm kind of stubborn like that. So that's A and that's B. So it's going to be A squared. Well, I already know A squared. It's going to be 12 squared plus B squared is equal to 13 squared. I know, and you also could have wrote it like this: 12 squared plus x squared is equal to 13. You can also write it like that, but I'm just kind of keeping in the Pythagorean theorem formula here. So I'm going to go ahead and square everything I need to. So that's 144 plus b squared is equal to 169. Well, going by the rules of algebra, I'm going to subtract 144, subtract 144, and I get b squared is equal to 25. Well, I'm going to square root this again, and then b is going to equal to 5, which means x will be equaling to 5. Okay? So those are pretty easy. Let's go down to problem number 3. And what makes problem number 3 a little more challenging for students is the fact that we're dealing with decimals. Okay, so problem number 3. Well, here's my right angle. Hey, there's my hypotenuse. All right, so I'm going to set it up as 11.9 squared plus, in this case, I'm just going to put the x squared, is equal to 14.7 squared. Okay, so let's go ahead and square root these decimals, and of course we're going to probably get some more decimals, but it's okay. We're in math class. Decimals are numbers too. So when I square the 11.9, I get 141.61 plus x squared is equal to 14.7 squared, which is 216. Well, if we solve exactly like the other problem, we're going to subtract 141. I'm running out of room here. So subtract 100, or messed up there, 141.61, and I'm just going to have to write it off to the side here. X squared is equal to 74.48, and I'm going to square root this, and I'm probably going to get a decimal, and I do, and I get an answer of x is equal to 8.63. So my answer here is 8.63. There's my answer. Okay. Now, as we're moving on, you can do problem number 4 on your own. You can do problem number 5 and 6 on your own. Um, Now, problem 7 and 8, it's basically a um, a right triangle question, except they just didn't draw the triangle. So in this case, notice you have an A, you have a C, but you don't have a B. So it'll be A squared plus B squared again is equal to C squared. That gives me 11 squared plus B squared equals 15 squared. And you guys can solve for that on your own. Look at question B for a second. Or I'm sorry, question 8. Notice that b is radical 6. So the way I would set it up is a squared is plus radical 6 squared is equal to 4 squared. Well, what happens to the radical 6 when I square it? Very simple. The radical comes off and it just turns into just regular plain 6 is equal to 6. Oh, that's not, it is 16. Okay. And then you could solve for that on your own. All right, let's look at problem 9, 10, 11, 12. We have 4 problems here, guys. Once again, if you want to pause this video and work on a couple of one of the, you feel free to do so. All right, now question number 9, we're just going to start here. Notice that everything is already solved. So all we're doing is just checking our work. So this right here is a right angle, so that means that would be my hypotenuse. So I would set it up as 9 squared plus 12 squared is equal to 15 squared. Now you might say, well, Coach Ford, can't you set it up as 12 squared plus 9 squared is equal to 15 squared? And I would say, yes, you could. It doesn't matter as long as you make sure you get the C correctly, the hypotenuse in the right direction or in the right position. So 9 squared, I believe, is 81 plus 400 or 144 is equal to 15 squared, which is 225. So basically, we're just checking, does 81 plus 144 equal that? It does. So we have checked our work. 225 is equal to 225. So everything is good. So I would say state if each triangle is right triangle. I would say yes, it is. Okay, and you guys can pause the video for problems 10, 11, and 12. And obviously, if it doesn't make a right triangle, then it is not going to work. But let's look at 10 because 10 has something funky here that we haven't seen. This is a right triangle. So this is 10 squared plus 2 radical 39 squared is equal to 16 squared. I'm just going to focus on the 2 radical 39. What happens when you square 2 radical 39? Well, the square actually gets distributed not only to the radical 39, but it also gets distributed to the 2. So in other words, you're looking at 2 squared radical 39 squared. Well, 2 squared is 4, times radical 39 is regular 39. So 4 times 39, that gives us 156. And you guys can finish out the rest. Okay, as we're looking through, there's some more problems. Pause the video. Just questions 17 and 18, don't worry about that. And here is all my answers. All right, I'm just scrolling through all my answers so you can check your work as I'm going through it. And if you deal with a radical, if you convert it to a decimal, that will be fine too at this stage in the game. All right, there you go. And remember, 15, 16, 17, 18, don't worry about them. And I hope you understood it, folks. And make sure you check out my next video on special right triangles. Thank you.